Welcome back, everyone. This is 3.5, factoring polynomials. So we're going to start out with the GCF. GCF stands for greatest common factor, so remember that. Now, when they talk about greatest common factor, that is different than your LCD, where LCD is your least common denominator. Greatest common factor means the factor that is divisible into all parts. So when we look at this problem, it says 9x to the 8th, positive 21x to the 7th, positive 33x to the 5th. So I'm going to write my 9x to the 8th, positive 21x to the 7th, positive 33x to the 5th. Now when we look at the coefficients, I'm looking at just the numbers. I'm underlining my numbers. So 9, the factor of 9 is 3 and 3. 21 is 3 and 7. 33 is 3 and 11. Well, I notice that they all share a 3. So I know that I'm dividing each of them by a 3. The next part is the variables. So x to the 8th, x to the 7th, x to the 5th. Well, this is actually x to the 5th with x cubed. This is x to the 5th with x squared. And this is x to the 5th with a 1. So they all share x to the 5th. So x to the 5th is what I'm also joining with that 3. And the question is asking you to factor out the GCF from the polynomial before. So they want you to factor out the GCF. They only want GCF. Well, in this instance, our GCF is 3x to the 5th, so 3x to the 5th is our answer. Now, if the problem wanted you to figure out the problem completely, so when we look here, this problem here, 9 divided by 3, so we factored out 3x cubed. So 9 divided by 3 makes it 3. I had 8 x's, took 5 away. I have 3 of them left over. 21 divided by 3 is a 7. I had 7 x's, took 5 away. I have 2 left over. 33 divided by 3 is a positive 11. I had 5 x's, took 5 away. There is no x. So if the problem wanted you to, any math problem, wanted you to factor out the GCF and then factor it completely, then you would end up in this situation right here. You cannot break this down any further than it already is at, because the power of 3, it goes power 3, power 2, power of 1. When you factor, you need to be either 4 terms if you start with a power of 3, or 3 terms with a power of 2 at the beginning. It has to be even numbers at the beginning. Moving on to our next example. So it says, factor the following expression completely by grouping. So grouping means we look at our piece, it says z, parentheses z minus 8, minus 7, parentheses z minus 8. So since they've already given you your starting values, look at what they have in common. This here is known as their GCF. So when you take your problem, you're dividing both pieces by the parentheses z minus 8. Now, you're not getting rid of it. It is just being factored to the front. So I'm going to write z minus 8 and left over. Well, z minus 8 divided by z minus 8 cancels out. You're left with a z here. So that's a z going in. Z minus 8 cancel out, leaving you with a negative 7 going in. So your final answer is going to be z minus 8 times z minus 7. We're going to move on to our next example. So this problem, it said factor by grouping. So first thing I noticed, it's 10x squared minus 30x plus 14x minus 42. So because they want us to use grouping, I'm going to take my problem, I'm going to write it down. And step 1, I'm going to place brackets around the first 2 terms, second 2 terms, keep sign in the middle. So what does that mean? So I'm going to put a bracket around the first two terms and the second two terms, and I kept that sign in the middle. So you're going to treat each bracket as its individual problem. So I'm looking here, and I want to pull the GCF. So step 2 is look at the GCF per bracket. So in this one, 10 and 30, they're both factors of 10. 2x's and 1x, they both share an x in common. So the GCF on this instance is 10x. In this one, 14 and 42. 14 is a factor of 7, so is 42, so they're both divisible by 7. This has an x, that has no x, so 7 is the only GCF. Step 3. You're going to pull the GCF in front of brackets, in front of each bracket. So I'm going to write it as 10x bracket, positive 7 bracket. And we're going to do regular division. So 10x squared, took out 10x, the 10's cancel, power 2, power of 1 leaves you with a plain x. Negative 30 divided by 10x, negative 30x, and 10x leaves you with negative 3. You go on to the second bracket. 14 divided by 7 is a 2 with an x. And 42 divided by 7 is a negative 6. Now, when you come to the situation here, notice that I did a 7 here. When I look into the bubble, 2x minus 6, they both are still factors of 2. So I'm going to pull out another 2 out of them. I am dividing out another 2 out of both of these. So you have 10x sliding down, x minus 3. 2 is factoring out, so 2 joins that 7. 7 times the 2 makes it 14. And now we become x minus 3. So step 4, you need for both brackets to match. So now when I look here, x minus 3 in the first bracket, x minus 3 in the second bracket, that is our new GCF. So I'm dividing by x minus 3 to both of them. So remember, x minus 3 is the first one. When I canceled out, that canceled out, leaving you with 10x. That cancels out with leaving you with a 14. Now, here's the last step. Looking here, it says 10x plus 14. Both of them are even numbers, so they have a GCF that needs to be pulled out first. So we're going to divide by 2, so a 2 comes out. 10 divided by 2 is a 5x. 14 divided by 2 is a 7. So our answer is going to be 2 on the outside, x minus 3, 5x minus 7. So on problems like this, we started out with step 1 by using brackets. There's a step 0 we're going to add in this problem because of the nature of the problem and how it ended up down here. Step 0 is going to be look for common GCF first. So if we had looked at our original 10, 30, 14, and 42, they are all even numbers. I would have originally divided everything out by 2, and then it would have reduced your values here so we would not have to do it at the end. Next example, it's actually where we start doing what they call the square root property method, or I like to call the Colombian method of factoring. It's going to help you factor polynomials, especially the trinomials, a lot quicker. So here we go. So in this example, it says z squared plus 8z plus 15. In this problem, it's a trinomial. First thing I notice is a power 2 at the beginning, which is what we want. Normally we have coefficients in front, which makes it easier. So here's how Colombian method, which is also known as your square root method, happens. Step 1, You're going to place 2 parentheses below the problem. So we have z squared plus 8z plus 15. And I'm going to write 2 parentheses sets below the first problem. Step 2. You're going to place the first coefficient into each and split the variable powers. So I'm going to write there's a 1 coefficient, so a 1 and a 1. Power 2 becomes z and z. You don't have to put the 1s there. That's implied that they exist. That is step 2. Step 3, you're going to multiply the first and third terms. Find factors that add to the second term, which is your middle term. So, a 1 times the 15. So that gives us a 15. I'm doing my x bar. So it said they need to multiply to the first term, and they need to add to the middle term. The middle term is an 8. So they need the 2 numbers need to multiply to 15 and have to also add to 8. Well, 15, 3 and 5, negative 3 and negative 5. The reason I did the two sessions is because 2 positive numbers multiply to be a positive number. 2 negative numbers also multiply to be a positive number. The bottom number happens to be a positive 8. So because it's a positive 8, I can only keep the positive 3 and the positive 5. So positive 3, positive 5. And in this problem, normally if there was something that can be reduced, you would pull out the GCFs. If not, then you're done. So in this one, it's z plus 3, z plus 5. So that's what it factors out to be. On the next example, I changed it where the leading coefficient is not a 1, where this is going to make a little bit more sense. So just give me a second. Okay, on this one, the leading coefficient in this one is a 3. So we have 3x squared minus 13x plus 12. So we're repeating this pattern. 3x squared minus 13x plus 12. Step 1 said, put parentheses underneath and put the leading coefficient number into both of them. So I'm going to write a 3 and a 3, x squared. We're splitting them to 3x and 3x. Step 2 says take the first number and multiply times the third. So 3 times the 12 is your 36. 36 is your crossbar. And you need to add 13 on the bottom. So 36, we know of 4 and 9, 6 and 6, 3 and 12. I'm just writing the positive versions of them for a minute. And we have to add. So 4 plus 9, that gives you 13. But because I need it to be negative 13, they need to both be negative. So I'm going to write a negative 4, negative 9. The last step that we didn't do on the last one is if you can reduce the situation, reduce it. When I look at this problem, 3 and 4, they're not divisible. But here, 3 can go into 9, so I'm just dividing both sides by 3 to reduce, and you're left with 3x minus 4, x minus 3. And there's your result. When we look at our next problem, it says 80x squared minus 28x minus 12. So before we can start our problem for doing Coulomb method of factoring, notice the coefficients 80, 28, and 12. They're all even numbers, which means we need to first pull out the GCF. So 80, 28, and 12. 28 we know is just 4 and 7, so it means 80 is 4 and 20, 12 is 4 and 3. So first thing we're going to do is take our problem and divide everything by 4. So we don't lose the 4. The 4 is on the outside of your problem. So we become 20x squared, positive 7x, negative 3. So first thing in this one, we did a step 0 instead of a step 1. So step 0 was pulling out our common GCF. Now we're going to go back into the Colombian method. Because we use brackets or parentheses here, we're going to use brackets. So bracket 1, bracket 2. Instead of doing 2 parentheses, we're going to use brackets. So remember the rules. It's the first coefficient, so it's 20. So I'm going to write a 20 for both and split the x's. Step 2 was the first term times the last term. So 20 times your negative 3, that's negative 60. It has to add a positive 7. So factors that multiply to 60, they add to 7. So when we look at our factors of 60, 60 could be 6 and 10, 5 and 12, 4 and 15. I gave you some possibilities. Now, notice that it needs to multiply to be negative, which means one number has to be a positive number, one number has to be a negative number, because they need to multiply to be a negative number, but they have to add to be positive. So if they have to be positive, the bigger number is your positive value, the smaller number is your negative value. So if I do positive 6 and 10, that gives me 6. I can only get to 6 here. This gives me a 7. This gives you 9 because I have 5 and 12. So I'm going to write 5 and 12. Now, in order to get positive 7, that means the 12 had to be the positive value. The 5 had to be the negative value. Then step 3, we need to reduce our values. So when we look at our situation here, inside 20 and 5, they're both divisible by 5. 20 and 12, they're both divisible by 4. And then you know you pulled out enough because 5 times 4 is 20, which happens to be your value at the start. If these two numbers down here multiply and are not the starting value, you did not pull out enough of a GCF. So these two numbers multiply, give you the 20, so we're reducing. The 4 sliding down. 20 divided by 5 is a 4x. 5 divided by 5 is a negative 1. 20 divided by 4 is a 5x. 12 divided by 4 is a 3. And you are factored. Moving on to our next problem. These are the type of problems that we call our perfect square trinomials. Perfect squares, which means the beginning numbers and the last digit numbers are perfect squares, which means I can take the square root of 4. It's a 2. Square root of 256, that is a 16. So what does that mean? It means that it follows a pattern. So perfect squares are a squared plus ab plus b squared, which break down to be a plus b, or 2ab actually. A squared plus 2ab plus b squared is a plus b, which is just a plus b squared. Or you can have the minus sign, a squared minus 2ab plus b squared, and that becomes a minus b again, or a minus b squared. So when we look at this problem, first thing we need to know is, can we use it? So square root of 4 gives me a 2, square root of 256 gives you a 16. How do you know if you can use it? The middle term here tells you it is 2ab. Well, this is my a, this is the b. So 2 times 2 times 16. That gives you 4 times 16, which is 64. 64 is the middle value. So when you see 4y squared plus 64y plus 256, you can just go ahead and draw two bubbles. Put the square root values of both of these at the beginning and end. Beginning and end. Plus sign in the middle, I'm putting a plus in the middle. So now here's the thing, 2y plus 16, even numbers. 2y plus 16, even numbers. I'm going to factor out a 2. I'm going to factor out a 2. 2 times 2 means it's a 4 on the outside, and you're left with y plus 8 squared on the inside. So there's two values. So again, Even numbers again, all three. So technically we could have done a step 0, which was pull out the common GCF since 4, 64, and 256 are all even, and gone that route. Or you can just do it at the end, depending on the problem. The last example, it's only got 2 terms. These are known as your difference of squares. And it means it's following an a plus b, a minus b pattern, which is also known as your a squared minus b squared situation. Which means, again, it's dealing with square roots. So you need to have perfect numbers. So if we think about it, because it says difference of squares, 49, that is a perfect number. I take the square root of it, becomes 7. 4 is a perfect number. I take the square root of it, becomes a 2. So you take your value, 49x squared minus 4. Immediately draw 2 parentheses, a plus sign in the first one, a minus sign in the second one. Take the square root of the first, take the square root of the second. So 49 makes it 7x, 7x, 4 makes it positive 2, negative 2, and that's your final answer. Now, if the problem, so this is allowed if the problem was 49x squared plus 4. This is D and E, does not exist. Those are imaginary values and we can't deal with those right now. So that is